Welcome back to my channel Kishore Sir Ki Pathshala. Let's do chapter number 3 for 10 Cbse, that is metals and non-metals. So we have been doing metals and non-metals from our 5th, 6th standard as such. We know what are these. Let's see this chapter as such. So let's start with the physical properties of metals. So we are going to see physical properties of metals and physical properties of non-metals also. Let's see physical properties of metals first. Alright. So metals, you know that in their pure state, they have a shiny surface as such. Right. For this, what we'll do, we'll take a sample of iron, copper, aluminium and magnesium as such. Right. Okay. Let's note their appearance. Right. Clean the surface of each of the sample by rubbing with sand paper, and let's note the appearance. Okay, so what you see here is that metals in their pure state have a shiny surface, and this property is known as metallic luster. Right, the shine what you see on the gold, okay, is nothing but what is luster. Right. Now, if you see that you take small pieces of what you take small pieces of copper, aluminium, magnesium, right, and try to cut them with a knife. Take Try to cut them with a knife and make your observation. Then what you see in this, you see that metals are generally they are hard, right, and the hardness varies from metal to metal. Okay, so if you see, if you hold sodium metal, right, and sodium metal, if you hold and if you try to cut the sodium metal, what will happen, right? So if you cut with a knife, you will see that a sodium metal, you can easily cut the sodium metal as such. So sodium metal is very easy to cut. Okay, so it's not that hard enough. So in the same way, if you take iron, so what will happen if I take iron? If I take iron, if I try to cut it, it's not possible to cut iron, right? So the hardness varies from metal to metal. Now then you will see metals can be beaten into thin sheets, right? It can be easily beaten into thin sheets. Okay, so if you take a block of iron and strike it 4 5 times with a hammer, right, what you'll observe? You'll observe that you can convert that into thin sheets, right? Okay, and this property of converting metal into thin sheet is called as malleability, right? So this is my malleability property. Okay, now if you see the electrical wires in your house, right, what you see with those wires? Okay, how are these wires? These wires are nothing but they are very thin wires as such. Okay, so the conversion of the metals into thin wire is called ductility, right? Conversion of thin wires, metals into thin wires is ductility. Okay, so malleability is what? Is sheets, right? So malleability is sheets and ductility is my wires, right? So MSDW we need to remember. Okay, right? MSDW, malleability is sheets and ductility is wire. Okay, so you can remember like this: Mahendra Singh Dhoni, wicket keeper, right? Okay, MSDW, malleability sheets and ductility wire. So if you see that gold is the most ductile metal, okay, you'll be surprised to know that a wire of about 2 kilometers length can be drawn with 1 gram of gold, just 1 gram of gold we can draw how much? 2 kilometers length of wire can be drawn, right? See, the ductility is one of the highest in the metals. Okay, so we are going to see some experiments which will show us that metals are good conductor of heat. Okay, and metals have high melting point, right? The best conductors of heat are silver, copper, lead, and mercury are comparatively poor conductors of heat. Okay, so lead and mercury are poor conductors of heat. Okay, here you see that metals, they have got ductility, they are good conductors. Sonority, what we are going to see, malleability we have just now seen, luster we have seen, right? And they have the mechanical strength. Okay, that's the reason you see that a lot of infrastructure is made up of what? Of metal. Usually the benches in your class made up of what? They are made up of iron, steel, right? So the mechanical strength is there with those. Let's see one experiment as such, an activity. So which will show us that metals are good conductors of heat. Let's take an aluminum or copper wire. Okay, then let's clamp this wire on a stand. Fix a pin to the free end of the wire using a wax. Okay, a free end of the wire is there, and what we are doing, we are fixing a pin to it. Okay, here is my wire, and I am fixing a pin to it with the help of a wax. Right. So now here you see it has been fixed like this. Right. Now what I am going to do? Now I am going to put a burner here and I'm going to ignite it. Okay. Now what will happen? After some time, you will see that this metallic rod, this metallic wire will become hot. Right. Okay. And what will happen? The wax will melt. Here the wax will, it will melt, and the pin which was attached to it, it falls off. Right. Wax will melt and the pin will fall off. Okay. Now, if you see this metallic wire, do this metallic wire also melts? No, the metallic wire is not melting as such. Right. So what is happening is there, we are supplying heat at this point, and what is happening, the heat is getting transferred. Right. Okay. So what is happening, that metals are good conductors of heat. Right. So this activity shows us that metals are good conductor of heat. Right. Okay. Let's see another activity. Let's prove metals are good conductors of electricity. Right. Metals are good conductors of electricity. Now, let us set up an electric circuit like this as shown in the figure. Here you see what is there, battery is there, bulb is attached to show us that if the bulb glows, it will show us that the current is flowing through the circuit. Then we have got the switch, right? Then we have got what clips here, A and B clip is there. Okay. In this clip, what we are going to insert, we are going to insert a metal piece. Right, we are going to insert a metal piece, and if we insert a metal piece and if the bulb glows, right, it will prove that they are a good conductor of electricity. If I insert a metal piece and the bulb doesn't glow, right, then what will happen? That will prove that metals are not a good conductor of electricity. Let's try to see this. Okay, so let us put a metal here in this middle, right, like this. Okay. So what do you see that? You see that the bulb will glow. Okay. The bulb will glow. If I put this metal piece like copper, right? So you'll see that the bulb is glowing. So what it proves? It proves that the metals are good conductors of electricity. They are a good conductor of electricity. That's the reason the wires that carry current, okay, if you see the wires carry current, you'll see that the wires are covered with an insulation, right, of PVC, polyvinyl chloride, or a rubber like material. Okay, and inside it's the wire. Okay, So these wires carry current, and you will see that a coating is being given from outer end so that the current will not come out and you will not get an electric shock. Right? Okay. So this activity proves that metals are good conductors of electricity. Let's see the property of sonority. Right? Metals are sonorous. What it means? If you take a metal bell, right now, you might have seen a metal bell, okay, and if you strike it, what you'll see, you get a sound, okay. When you hit a metal hard, they produce a sound, and that sound produced on striking a hard surface like metal, okay, is that is called to be sonorous, right? So you have seen the school bells are there. Usually they are made up of metals, right? Why? Because on striking it gives a sound, right? And they are sonorous in nature. So students, I'm sure you have understood today's topic of properties, physical properties of metals. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.